So far, we've actually had two SDK example projects. One of them was Hello World, and the other one was Blinky. Now what we want to do is create our own new C/C++ project. We can do that by clicking here in the MCO Expresso ID Quick Start, or up here in the Project Explorer, or we can go up here and say File, New, and create a new C/C++ project here. At this point, it's asking us to actually select the board. We have a great number of boards here, and there's a number of other target boards down here. But what you're going to find is the target it knows is a K6 something. Now, these are all using K6X microcontrollers. And as you know, a microcontroller is a complete computer on a chip. And there's a whole bunch of different boards here that have a K6 something microcontroller on it. So if we look at the Freedom K64 and we select that, it's going to tell us that that particular microcontroller is an MK64FN1M0VLL12. That's the actual microcontroller that's on the Freedom K64. Now it's asking us to put in a project name, and it told us in the lab to actually put in blank project. So I'll put in blank _ project. And it also asks us over here, instead of using Uart, to use SemiHost. Now, in LAB3 Part 2, it talks about analyzing the source code, and there's lots of good information here about board init boot pins and board init boot clocks. Now, the board init boot peripherals is used to initialize any onboard peripheral devices, such as LEDs, push buttons, and so forth. And the board init debug console here initializes Uart0 to communicate with the PC at the baud rate here specified, which is 115/200. And the function prototype is also in board.h. Now, functions such as printf, scanf, putchar, getchar, and so on that we've seen before originate in the standard io.header file, and FSL or Freescale Debug Console.h converts these to uppercase. That's why we have to type these in uppercase when we're doing our main program. Now, before we get into part 3 of Lab 3, one of the things we want to do is take a look at perspectives. And we find that out under Window. And we go down here to Perspective. Then we can say Open Perspective. And we have a number of different ones such as Clocks, Debug, Develop, Device Configuration, Peripherals, and so on. And we can also hit Other. If we hit Other, we have all the different perspectives listed here. And the most common one we want to look at is C/C++. So we click here, we'll always go back to this screen. So let's go again and take a look. Sometimes you'll see up here different perspectives listed up here, such as Develop, Pins, C++. So you can get to these right away. But if you can't, then Window here, going down to Perspective, and Open Perspective will allow you to get to the other, where it will show you all the possible perspectives that you want to get at. Now, the one we want to take a look at today is Device Configuration. So if we double click on this, we'll get all the things that shows up on Lab 3 Part 3, such as pins. Now, it mentions in here that if we click here, we'll disable the generated code from here. We can also click here to get rid of the generated code for clocks, and we can click here to get rid of the generated code for peripherals. So just clicking on these will enable or disable these particular functions. You'll notice up here we've got configuration general information, the name of the .mex file, which is blankproject.mex, and it's imported from the blank project itself, and it's stored under this particular thing where it is on my memory stick here. Configuration for hardware information. We have the MK64FN1M0 3X's and a 12 because there's a number of different types of chips in this range, and ours happens to be the VLL version. And it's a Cortex M4, and you can see here the SDK is version 2.0. Now to get out of this, you can just hit close, and then you can go back to any perspective you want. A lot of times you'll see this little box up here with a plus where it says Open Perspective, and when you click on it, it again gives you all the different perspectives. We're going to go back to the C/C++ perspective. You really have to get comfortable with where you are in MC Expresso. It's very large, and getting to the right perspective is very important. Now, another way to get there, you can actually right mouse click here on blank project, and you can go down here to MC Expresso Configure Tools and Open Tools Overview, and basically you'll get to this version of this here. Now, there's a number of ways to get back to the pins here. You can also click on blank project MEX, and it gets here. Now, One of the things that you sometimes might do is click on this by mistake and get rid of it, and oh my god, and even if you want to get rid of this, and it's very hard to get that diagram back. Simplest thing to do is then go to Window, go down here to Perspective, and go to Reset Perspective, and click here on Reset Perspective, and everything comes back. Now when we get to the pins, you're going to see a diagram here of the 100-pin CPU that we've got on our Freedom K64. And over to the left here, we're going to see a number of pin names and labels and so forth. And if we scroll all the way down here, we can see that Uart0, which is our receiver, which is our keyboard, and Uart0 transmitter is what's going to go to the screen. These things are highlighted here, but they're not in our peripherals down here that have been mentioned. So what we want to do is actually add those. And the simplest way is to actually click on this and it adds it here. Click on this and it adds the transmitter here. This is exactly what you should see when you're looking at this on the lab. However, if you wanted to use the board init pins thing here and go down, as it says in the lab, to go down to init debug Uart pins, you're going to find that it's going to get rid of the SWO. If that's important, then you might want to just go back here and go to the plus here, go back to C++, and go back here and get rid of the MEX file that it was creating and say OK. Then when we go to our pins utility here, we can click here and here, and it's going to give you exactly what you have in the lab. Go from the pins tool to the clocks tool. We can go up here to the plus here. We can go here to clocks, double click, and we're in. And when it drops you in, you can go from the clocks table here, which is showing us our external oscillator is working at 50 megahertz, to an actual clocks diagram, which shows us all of this. And you can see here's our external oscillator at 50 megahertz, going through an oscillation selector here, going into a phase lock loop. Now the phase lock loop divides by 15 and multiplies by 36 to give you 120 megahertz going through here. Now as it goes through here, you're going to have 4 dividers. Output divider 1, which is going to divide 120 by 1 and give you 120 megahertz here on the core clock and the system clock. Output divider 2 is going to divide by 2, and that's going to give us 60 megahertz, half of 120 on the bus clock. Dividing by 3 is going to give us on the output divider 3, 40 megahertz coming to the flex bus clock, and output divider 4 divided by 5 is going to give us 24 megahertz coming out to the flash clock. You can actually try changing some of these things. I can go over here and let's try changing 50 to something else. Let's try changing that to 100. And we can see a whole bunch of red things happening here because that is not how the things are set up, and that's going to mess things up pretty badly. We put 50 megahertz, everything works again. Now we can do some other stuff here. We can say, well, let's try and make the output here divider different. We can click on here and say divide by 2, and you can see that we've got some problems already. So again, let's go back here and divide that by 1. We might even be able to go up here and just change this to 60 here. And you can see only the core clock is going to be a problem here. We can try changing the system clock to say 60. And you can see only the system clock is going to be a problem. So it's best to leave these alone unless you know exactly how to compensate for the changes that you're making in these clock values. To change from the clocks view here to peripherals, we can go up here again, and we can go down here and click on peripherals and say open. And you'll notice here when it comes up, it's components here, middleware, peripheral drivers, NVIC, which is nested vector interrupt controller. We can switch over here to peripherals, and we can see down the left-hand side that the only thing that's listed here that's highlighted is a nested vector interrupt controller. Everything else is not listed or selected. Now if we click here, we're disabling the nested vector interrupt controller. If we click here, we re-enable it again. We have a way by going through this to actually use some of our GPIOs. We can go here, click on GPIO, we can say OK, and then it's going to allow us to configure it and do things here, or we can actually just get out of here and we can say remove, and when we say yes, it's just back to where it was. So we can actually configure these in this utility here, which is pretty cool.